Hey everyone, good morning, good afternoon, good evening. Welcome to Data and AI Fast Track. I am Farhan Chaudhary, Data and AI Evangelist at Snowflake, and today's session is the one that I've been looking forward to for weeks. See, it's Earth Day next week, and we are not waiting because here's the thing: good intentions are nice, posters are nice, hashtags they're also very nice. But the planet does not run on nice. It runs on evidence. It runs on patterns, on data. And today, we've got three incredible people from Altus Consulting who are going to show you exactly how data and AI are being used right now to protect water, cut emissions, save endangered species, and rethink how we deal with waste. So, this isn't theory. These are real projects, real impact, real results. So let's get into it. Quickly about me, I'm the data and AI evangelist at Snowflake, which basically means I get to spend my days talking about the intersection of data, AI, and real world impact. And today's session, this is exactly why I love this job. Now, before we bring on our speakers, very quick housekeeping for all of you. The World Economic Forum estimates 78 million net new jobs will be created by 2030, driven by data, AI, and green transition. 78 million. Remember that number. Yeah, it's a huge number, I'd say. That's not a distant future. That's 4 years from now. And a massive chunk of these roles sit at the intersection of sustainability and technology. The skills you build today, the ones our speakers are going to walk you through, are exactly the skill the world needs. So, say if you have questions or concerns about where your jobs are headed, where we are headed in the future, then remember there is a world of careers opportunities waiting right in front of you. Now that said, everyone here live today earns a certificate of attendance. Post it on LinkedIn, tag us, tag our speakers, tag me, tag at Snowflake, hashtag Snowflake Fast Track. Attend all of our events and you unlock an exclusive ebook from our speakers. And please drop your questions into the Q&A panel as we go. Our speakers will tackle them live at the end. Now, let me introduce the people who are going to make this session unforgettable. From Altus Consulting, we have Hyun, co-founder and executive director at Altus. Hyun leads the strategic vision for how organizations use data to drive real outcomes. She has worked across water utilities, energy, environmental markets, and waste management. Basically, if data is protecting something on this planet, Hyun's probably been involved. Then we have Phoebe. Phoebe Song, senior consultant at Altus. Phoebe is on the ground implementing the solutions that turn messy, siloed data into actionable environmental insights. And then we have Des Virana, head of advisory and AI at Altus. Des is at the frontier of applied AI for sustainability, is building the models and frameworks that make these use cases actually work at scale. Three people, four use cases, one mission: use data to protect the planet. But before we dive into these use cases, Hyun is going to set the stage with something I think will reframe how you think about data entirely. With that, Hyun, over to you.
Thank you, Farhan. Hello, everybody. So I'm sure all of you, know the derivation of the term data from the Latin datum, literal meaning of which is a thing given. And the term came into use in the 1640s in mathematics. And but before we even had the term, we'd been amassing data. The earliest evidence of the human use of data goes back 19,000 years to what is sometimes called the Big Baboon, which was actually a baboon bone called the Ishango bone found in the Congo. Since that baboon bone to now, we have been increasing our collection, collation, and consumption of data in ever increasing amounts to today, which according to the latest estimates, we collect 402.74 million terabytes of data per day. So why do we do this? Our brains love patterns, equations, mathematics. These are all factors which help us understand our world and shape it. And all of this is driven by data. My own journey around data began at the beginning of my career as a new freshly minted graduate when I joined the corporate world. And I worked within a organization that focused upon selling superannuation to a whole bunch of clients. And the marketing system and sales system that I worked on, precursor to the modern CRM, was full of data, customer data, contact data, sales data. And what I quickly realized was that despite the complexity of the system at that point in time, the real value in this system was the data. It was the information that helped drive the decisions for the organization. And since then, I founded Altus, and my career has all been about how to assist organizations and individuals extract value and positive outcomes using data. I'm just trying to move on my... Okay. What I do believe is within Altus, our organization is based not just around data, but the intersection of the human qualities. So when we apply data, we're in synergy with our human qualities of sight, voice, imagination, and care. We bring about discernment of decision and clarity to our actions and decisions. And data can illuminate to help us see and understand situations and the trends and the patterns hidden within, making the invisible visible. Data can also light the way, providing context and clues to guide us in our choices, which brings forth the important value of human responsiveness. That human responsiveness goes beyond corporate decision-making and brings forth our human values of compassion, duty, care, and custodianship, which can bring voice to needs within our world that otherwise can stay mute. Of course, in the line of work that we do, we're not always given the opportunity to apply these ideals, but we have at Altus had the privilege of many opportunities where we can apply our data skills for real human and sustainable impact. Phoebe today is going to speak to you about one of our cherished stories where nature was given a voice through data. Phoebe, over to you.
I worked on a few years ago, the Tasmanian Devil Tracker Project. It's a good example of how we approached a very real-world problem with very real constraints. Since devil facial tumour disease emerged, around 80% of the Tasmanian devil population has been wiped out. That statistic alone gives some sense of how serious the situation is. Luckily, organisations like the Tasmanian Nature Company are actively looking for better ways to protect the last remaining disease-free Tasmanian devils in the wild. I was involved in this project through volunteer work with them, and it became a strong example of how data can be used for good. I'll start by giving some background on the organisation and the context, then walk through the problem we tackled, the constraints we designed around, and the key lessons that came out of it. So what is the Tasmanian Nature Company? They're a specialist nature tour and conservation organisation based in the Tasman Peninsula. They run a groundbreaking wildlife centre known as the UnZoo. I don't know about you, but whenever I go to a traditional zoo, I often feel a little bit sad for the animals that are stuck there, behind fences and enclosures. The UnZoo is a complete reversal of that traditional zoo model. There are no obvious enclosures. Cages and barriers are removed or carefully concealed, and visitors are invited into the animals' natural habitats. Wild animals are encouraged to interact naturally with their environment. This gives them more dignity, freedom, and self-determination, and at the same time gives humans much more personal and memorable encounters with wildlife. The bush surrounding the UnZoo attracts a huge range of native animals. Some of the animals that live there include possums, wallabies, echidnas, bandicoots, wombats, spotted quolls, and almost 100 different species of birds. But most importantly, this area is home to the last wild, disease-free population of Tasmanian devils anywhere in the world. Before dingoes were introduced to Australia around 8,000 years ago, Tasmanian devils were found across the whole of Australia. Unfortunately, dingoes wiped them out on the mainland, but because Tasmania had already separated from the mainland, the devil population continued to thrive there. That's why Tasmania is the only place in the world today where Tasmanian devils still exist. The UnZoo itself is located on the Tasman Peninsula, which turns out to be the ideal location for this sort of conservation. The Tasman Peninsula is almost an island. There's a canal with a single bridge that separates it from the rest of Tasmania, and it's very unlikely that a Tasmanian devil would cross that bridge, but barriers have been put in place to prevent that. And all of this separation exists for one reason: the devil facial tumour disease. The disease emerged in 1996, and there is no cure. Tumours form in and around the mouth, which eventually affects the devil's ability to hunt and eat, leading to starvation. The disease spreads through playing and fighting, completely normal behaviours for Tasmanian devils. In diseased areas, nearly all sexually mature devils become infected and succumb to the disease. Juveniles as young as 1 year old can be infected. This has resulted in populations with a very young age structure, where females often only have one breeding event instead of the 3 that they would normally have. If this disease gets into the UnZoo, it will only be a matter of time before Tasmanian devils are extinct. Prior to 2018, devil facial tumour disease had made its way onto the Tasman Peninsula. However, the Tasmanian Nature Company successfully eradicated the disease from the area and has remained disease-free ever since, making this region the last safe haven for Tasmanian devils. To help protect the devils, the Tasmanian Nature Company set up what they call the Devil Tracker Project. This project monitored local wild devils using infrared cameras placed around the UnZoo. Whenever a camera detected a movement, it would take a photo. As you can imagine, those cameras captured a lot more than just Tasmanian devils. There were also 3 traps set up with food each day, which increased animal activity in front of the cameras. At the time, the daily routine looked like this: drive to each camera and collect the SD cards and replace the food. Manually review every single photo taken in the last 24 hours. Find the photos that contain devils and carefully check those photos for any signs of facial tumour disease or injury. This work was extremely time-consuming and boring, so why not automate it? The core problem we were solving came down to 3 questions. First, is there a Tasmanian devil in this photo? Second, if there is, are there any facial tumours or injuries? And third, can we identify individual devils in the photos? The key insight we had early on was that humans shouldn't be spending their time answering the first question. Individually, each photo is just a moment in time. But taken together, and with that third question, these images start to build a picture of where individual devils go, how often they return to the same locations, and how their behavior changes over time. As the population continues to decline, this kind of information becomes increasingly valuable. There is literally no other place in the world where you can collect this sort of data on disease-free wild devils. So while the immediate focus was health checks, it was also a longer-term opportunity to better understand wild devil behavior without interfering with it. One of the biggest constraints we had to work within was the environment. The UNZU is remote, with limited and unreliable connectivity. Connectivity was so constrained that image data was posted to us on USBs, quite literally USBs in the mail. Once we got those USBs, we started with manual sorting and labeling of the images, using a Python tool called Label Image. This involved drawing bounding boxes around animals and labeling them. This works well when you don't have many images, but we had a lot, around 1,500 initially, but it gave us a really good feel for the data. Most of the early images were devils, with a couple of cats mixed in, which caused the model to assume everything was a devil, even though we had labeled the training image cats as cats and devils as devils. This was an early reminder that AI will always find the simplest patterns available to it, whether or not those are the patterns you actually care about. There are over 100 different species that live around the UNZU. Some of the photos were in color, while others were grayscale. At night, many animals look extremely similar, especially when they only appear briefly or at a distance. For some animals, like pademelons, we only had 2 photos, nowhere near enough to recognize every species reliably. And importantly, we didn't need to recognize every animal. The Devil Tracker project was about tracking devils, not cataloging wildlife. So we deliberately simplified the problem and made a devil and non-devil class. Even after simplifying the classes, the model still tried to cheat by learning the background instead of the animal. Lighting, scenery, and camera placement became shortcuts. This reinforced an important insight. AI is smart, but it's not that smart. It can only evaluate what you give it, and any bias in your data will surface very quickly in the model's behavior. At that point, we realized the most important step wasn't classification, it was reducing noise. We introduced an automated filtering step that identified whether an image contained an animal at all, without attempting to identify what it was. It would find an animal in the frame, draw a bounding box around it, crop at the bounding box, then we resized all the images to make them square and change them to grayscale. This reduced the amount of variables in each image to force it to focus on the actual animal. At this point, we also added a lot more images to the training dataset, trying to have a good selection of animals that were in the UNZU. This allowed us to remove empty frames, normalize what the model saw, and consistently focus attention on the subject of interest. In practice, this duplicated what humans were already doing, but continuously, consistently, and fast enough to support daily review. With the filtering in place, the system was able to reliably surface Tasmanian devil sightings, allowing staff to prioritize health checks. At the same time, the filtered dataset created a much cleaner foundation for longer-term health and behavioral insights. In testing, the model still made a couple of errors, but those mistakes actually increased our confidence that it wasn't cheating. They were easy to explain, and most importantly, they didn't reduce trust in the system. The model wasn't making health decisions, it was making sure humans saw the right images at the right time. So before, we had thousands of images manually reviewed, taking up hours of time each day. And after, images are filtered daily so humans can focus on health checks as early as possible, while also building a dataset rich enough to support deeper insights over time. This story isn't about fancy tech. It's about using evidence to focus human efforts where it matters. Des is going to share a simple way that anyone can apply that thinking to their own work.
Thank you, Phoebe. What I want to take from that story is not the technology, it's the discipline. Before the team touched a single tool, they answered 3 questions. What are we trying to protect? What is getting in the way of seeing it clearly? And what decision does this need to enable? That sequence is what made the project work, not the model. It's the thinking before the model. I want to show you what that same thinking looks like when you apply it to 4 very different problems, real organizations, real environmental stakes. Just to be clear, none of what I am about to show you is exotic. None of it requires a large team or multi-year program. What it requires is the discipline to ask the right questions before you reach a solution. So we have 3 questions. Let's see how they apply across these use cases. So the first one is in relation to water. That's what we're trying to protect. A finite natural resource that is foundational to human life and increasingly under threat. Climate change is squeezing supply, growing populations are increasing demand, aging infrastructure is leaking water into the ground before it ever reaches a tap. For the water utilities we work with, this is not an abstract environmental concern, it's a daily operational reality. And for too long, the response has been reactive. A customer calls, a road subsides, somebody notices something unusual, and by the time the leak is confirmed, enormous volumes of water are already gone. The data existed. IoT sensors are across the network, smart meter readings are there from residential and commercial customers, and they exist in asset and operational records. But all of these sit in separate systems that rarely speak to each other. So the utility had almost no insight. They had the data, but almost no insight. So that is the starting point. So the second question, where is the noise? The noise here is volume and fragmentation. Sensor readings rolling in continuously across thousands of network points, and most of it is normal. It's routine and it's expected. The signal, the anomaly that tells you that a leak is forming before it becomes a crisis, is buried inside all of that noise. Without a way to separate normal from abnormal at scale, teams were doing what Phoebe's team was doing before the project. Reviewing everything, missing things, reacting too late. The infrastructure also created noise. Data sitting in network systems, asset systems, customer billing platforms, and telemetry feeds with no common foundation. You cannot answer the question, where are we losing water right now, if the data you need to answer it lives in 4 different places and can't be joined. So what decision does this need to enable? 2 decisions, really. The first is a maintenance and investment call. Which parts of the network are at highest risk? Where do we send a crew first? The decision is currently being made on instinct and historical precedent. Connecting sensor data, smart meter patterns, and asset records to that specific decision replaces instinct with evidence. Utilities can detect abnormal usage patterns that indicate leaks, identify weak points earlier, and prioritize based on what the data actually shows, rather than who raises the loudest concern. The second decision is a customer one. When a leak is detected on a private property, how can the customer quickly be contacted and informed? That decision sits between a utility and its community. Data makes it faster, more accurate, and more trusted. The environmental outcome is straightforward. Less water lost, more efficient use of a resource that cannot be replaced. The second use case is around clean energy. So what are we trying to protect? The integrity of the commitments being made about the future of the planet. Sounds pretty grand, but here's what it means in practice. Clean energy organizations are expected to accurately report their emissions, demonstrate transparency and accountability, and build confidence with regulators, investors, and communities. Those expectations are only going to increase. The sustainability commitments being made right now by organizations, by governments, by entire economies are only as credible as the data underneath them. If the data is unreliable, untraceable, or inconsistent, the commitments lose meaning. And we cannot afford for them to lose meaning. So where is the noise? The noise is in the reporting process itself. Spreadsheets passed between teams, manual reconciliations that consume weeks of effort of each quarter. Scope 1 and Scope 2 data sitting in different operational systems with no common structure. Data that cannot be traced back to source, so when a regulator or investor asks how a number was derived, the answer is a long silence followed by a spreadsheet trail that nobody really understands. So compliance teams are spending the majority of their time managing this noise, which means they have almost nothing left to actually understand what is driving their emissions or how to reduce them. They're too busy reporting. No time for improvement. So this is a significant problem when the point of the whole exercise is actually to drive real change, not just produce a document. So this requires two decisions to be enabled. The first is a reporting decision. Can we report our emissions accurately, consistently, and with full traceability? It sounds like a compliance exercise. It is, but it's also the foundation for everything else. If you cannot trust the number, you cannot act on it. Altus works with clean energy organizations to modernize their data foundations so that emissions data can be automatically ingested, validated, governed, and traced back to source. That creates a single source of truth. The reporting decision just becomes reliable. The second decision is more important. Once you trust the data, you can ask, what is actually driving our emissions? Which parts of our operation have the biggest impact? And where do we act first to reduce it? That really is the decision that matters. Data becomes a tool for action, not for disclosure. Third use case is in relation to environmental offsets. So what are we trying to protect? Trust. Specifically public trust that the environmental markets we've built to manage biodiversity are actually working. So here's the context. When development occurs and habitat is destroyed, offset schemes are designed to ensure no net loss of biodiversity. The developer is required to protect or restore an equivalent area somewhere else. And in principle, it's a sound idea. It balances economic growth with environmental protection, but it only works if the data behind it is credible. If you cannot demonstrate with confidence that an offset is delivering real environmental value, you are not protecting biodiversity. You're creating the appearance of protecting it, which when the stakes involve species survival, it's arguably worse than doing nothing at all. The real example behind this is the use case for New South Wales Biodiversity Offsets Scheme. A program that spans regulatory teams, market operations, scientific and ecological data, and economic and policy analysis. All of it critical, all of it fragmented. So where is the noise? Once again, the noise here is in fragmentation and the absence of a shared foundation. Data distributed across multiple systems and teams, no clear source of truth, manual, high-effort regulatory and ministerial reporting that consumes resources without producing confidence, low transparency for market participants who need to trust that the scheme is functioning as it was intended. So the risk is not just inefficiency, it is erosion of trust in the scheme itself. When nobody can say with confidence what is actually happening on the ground, the market stops functioning as a genuine environmental protection mechanism. So what decision does this need to enable? It's the credibility decision. Can a regulator defend the scheme to a minister? Can an environment trust that the offset they're buying is real? Can a member of the public look at the program and believe that biodiversity protection is actually happening? So Altus worked with the program to establish a shared understanding of the current state data challenges, defining a clear target state aligned to environmental and regulatory goals, and then design a practical governance foundation so that data could be trusted, explained, and defended. This was not about deploying technology. It was about enabling confidence in environmental decision-making. When the data foundation is sound, the scheme can demonstrate credible biodiversity outcomes, improve reporting confidence, and build the public trust that the market depends on to survive. Data governance in this context is an environmental intervention, not an IT project. Okay, the final use case is based on waste. What are we trying to protect in this use case is the possibility of a circular economy. The idea that resources do not have to be used once and buried. Landfill capacity is finite, populations are growing, recycling contamination remains a stubborn problem that good intentions alone have not solved. The infrastructure exists and the community intent is generally there. What is missing is the visibility to understand what is actually happening in the waste stream at scale and consistently enough to act on it. So where is the noise? The noise sits at two levels and they compound each other. At the collection and processing end, data from fleets, sensors, processing facilities, and recycling streams sit in disconnected systems. Waste composition, contamination rates, and recovery outcomes are not visible in any integrated way, and decisions about where to prioritize, what to fix, how to improve are being made without the information needed to make them well. At the community end, contamination behavior is only ever measured in isolated cases at postcode levels surveys, and that is not enough to understand behavior at scale or identify communities that need to be targeted for education or designing interventions that actually shift habits over time. Without addressing both of these levels, you're optimizing only parts of the system that you cannot fully see. So final question, what decision does this need to enable? Again, this is two decisions. The operational decision, where do we prioritize maintenance, processing investment, and recovery effort to get the most value out of what we are already collecting? Capturing data from collection systems, sensors, and imaging technologies, then analyzing waste competition and contamination patterns turns that decision from a guess into an evidence-based call. The behavior change decision. Which customers, which communities, which segments need targeted education to change how they sort at home? You cannot design effective behavior change programs without understanding behavior at scale. Data makes that possible, and when you get it right, the outcome is not just better recycling rates. It is the foundation of a genuinely circular economy, where resources are recovered rather than lost. So, 3 questions, a few use cases. Questions are, what are you actually trying to protect? Where is your noise? And what decision does this need to enable? Every one of those use cases started in the same place, not with a tech selection, but with a budget, not with a budget conversation, with clarity about what mattered, what was obscuring it, and what needed to change as a result. The technology in each case is different. The scale is different, the organizations are different, but the logic is identical. And it is the same logic Phoebe's team applied in a remote corner of Tasmania with data arriving by USB in the mail. I want to leave you with this because we are talking about Earth Day, and the problems that matter most right now, the ones involving water, biodiversity, emissions, the systems that sustain life on this planet are not going to be solved by technology alone. They're going to be solved by people who care enough to ask the right questions and who are disciplined enough to follow those questions all the way through to action. Data is not the answer. Data is what makes the answer visible. Hyun opened today by talking about data making the invisible visible. Phoebe showed us what it looks like at its most human. These 4 use cases show us that the same discipline scales, and the framework is the bridge between that inspiration and the work you go back to do. Let's use it. Back to you, Farhan.
Thank you so much, Des, and thank you, Hyun, Phoebe, for this incredible presentation. I think I resonate with the statement that you just made, Des. The fact that data is not the answer. It is what makes the answer visible. And if we ask the right questions, then we get better answers. And that's what we are after, using data and using the right human intent. So thank you so much for sharing that with us. I'm deeply moved and inspired by all of your stories. Um, we have talked about 4 use cases, 4 completely different domains, connecting with one common thread, that is data. Data is what makes invisible visible. And AI turns that visibility into action. Now, I don't know about you, but the Tasmanian devil story really got me. 80% of the population gone. Data is how we fight back, and that's incredibly powerful. So okay, that's it. It's your turn. We've got all the 3 speakers here, and they're all ready for your questions. So drop them right now in the Q&A panel. Water, energy, biodiversity, waste management, even career advice on getting into sustainability tech. Nothing is off limits. While we wait for a few more questions from the chat, I did note down a few questions for all 3 of you, Hyun, Des, and Phoebe. If that's okay with you, I might just want to ask some questions from my side.
Of course.
All right, Hyun, across all of these 4 use cases, what's the single biggest barrier you've seen organizations face when they are trying to use data for sustainability? Is it the tech that is limiting? Is it the organizational culture, the people, the process, or is it inherently sitting inside data quality issues?
I think all of those factors are, of course, important. But I think the data quality sits at the core of the challenge. I think even if you get all those other factors right, without the data quality and without being able to build trust in that data, you're still at a loss.
Very well put. Thank you so much, Shan. Now, Des, AI is a very hot topic everywhere. But in sustainability, where do you see AI having the most immediate practical impact versus where it's more still of a hype than a reality?
Firstly, we should extend it to data and AI. We've been talking about data and data making the invisible visible. The second thing is there's a lot of interest and hype, and there's a lot of fun as well in relation to AI, right? And I always say AI is for everyone, but it's not for everything. Let's, as individuals, first and foremost, make some choices with how many funny pictures and videos we want to create using AI, because there is a tangible impact to the environment every time we run one of these prompts in any of the systems. On the second front, I think from an enterprise perspective, we start simply. What is the problem we're trying to solve, and go from there.
I see. I completely agree with you, Des. AI not for everyone, but not for everything. In fact, I was speaking, and this is a personal anecdote from my own life. I was speaking with somebody very recently where they were talking about how, and everybody uses AI assisted tooling nowadays. For their work, for their personal life, for creating itineraries and what have you. So somebody was asked a question to the model, and the model came back to them with answers in a bulleted form. And then they wrote back to the LLM saying that, hey, I don't need this in form of bullets, but I need this in in an Excel spreadsheet. Can you reformat it? And they told me that I got these results from the model, and the results were great. But I went on to ask to them that, hey, did you ask AI to first change it from a bullet list to a Excel spreadsheet? They said yes. I said, I think we have to be more mindful of some of the things that we can actually do without having AI to do it for us, because there is a very real impact that goes behind these. This is not free, by the way. Anyone who is watching today's webinar, any AI prompt that you put in there, it costs tokens, it costs compute. Compute comes from energy. and energy, as you know, with the with the sources that we have today, it's limited. So think maybe twice when you ask AI to maybe correct an inverted comma for you. Maybe we can try doing that ourselves. That's the personal story that I have very recently. So thank you so much, Des, for sharing that. Now I'll turn to Phoebe for the other question. Um, Phoebe, you talked about a very human side of the intersection between technology and sustainability, yes, and data and AI and sustainability. But if somebody really wanted to get into this domain, what skills or experience would you tell these aspirants to prioritize?
For me,
Yeah,
it would be thinking creatively, not just applying standard solutions. You've got to be able to think outside the box and have a genuine passion for the problems you're trying to solve. And on top of that, you have to be able to explain technical concepts to non-technical colleagues. Sustainability data, you're going to be working with a wide range of people who have varying degrees of comfort with data and AI. So if you can get your message across and be able to discuss the challenges that you're facing with them, then you'll be able to drive real change, and also understanding trust, and it'll lead to better decisions.
excellent, fantastic. Um, so we are getting a few questions live as well. I will put it out to the panel, and I'll let anyone of you pick it up. Probably I'll first pose it maybe to Hyun. This question comes from somebody from our audience who asks, how can we leverage AI to solve an issue with dam safety management?
Wow, that's a powerful question, an interesting one. I think one of the capabilities of AI is visual. There is a lot of work that's available now that enables a visual capturing of infrastructure, and I think that we've done plenty of work across different utilities where the AI capability to analyze the visuals can really impact. And I think some of the stories that both Phoebe and Des spoke of can be applied in that particular situation, and IoTs that are obviously involved within that monitoring.
I think, Farhan, a couple of use cases. So the visual images in terms of individual safety. So, we're coming down to, well, what is safety management, right? And there's a number of different use cases that can be applied and are applied in dam safety as well as other areas of safety. So visual images for human safety, predictive maintenance, identification of leaks. There's so many different areas that can be done in that way.
Thank you so much, Hyun, Des. And for the member of the audience who asked this question, if you're interested in knowing more about some of these use cases, you should definitely reach out to Hyun, Des, and even to our team here at Snowflake. We have partnerships with the likes of Landing AI, and they specialize in the likes of visual predictive maintenance, where that Des just said, right? It depends on what kind of use case you're targeting. Amar, I think that question came from you, so thank you so much for asking that. You can go to Snowflake Marketplace and find the native application that we have from Landing AI. By the way, Landing AI was founded by one of the biggest researchers in deep learning, that is Andrew Ng. If you're already in the AI space, you'd know who I'm talking about. So just find out more information. You'll see there are a lot of solutions that are out there already off the shelf, and we can talk more use cases. So thank you so much, Amar, for asking that question. Phoebe, there's a question for you from the audience. The question is, why can't we use data in 3D, 4D model to identify the right animal or object accurately rather than guesswork?
So this project was a few years ago. If we did it now, we'd probably do it a little differently, maybe even using Snowflake Intelligence. But yeah, we had a lot of technical constraints, especially with the image data. So as I said, they'll post it on USBs, and we had to try and come up with a very simple way to pull out the images that we needed. So for us, that was, trying to use something basic, not going to 3D or 4D, just sticking with 2D.
Excellent. I will ask another question to Des, and this is more of an open-ended question. Des, what is one of the most exciting projects that you're working on as we speak, and why does it keep you excited, keep you up at night?
Oh, it's a big. There's a few, Farhan. The one that relates most to sustainability is in the waste management space, and working with a large waste management company in Australia across a number of different parts of their business, helping them understand where the opportunities are to manage their their business and their circular economy that they're building for themselves, right? So whether it's waste management, water management, oil and technical services, or as it relates to how they work with their customer. So engaging their customer, their business or direct to consumer customer, and using the information both to educate the customer as well, deliver a better service, and improve environmental concerns as well.
Excellent, excellent. Now, one common question for the whole panel, and you can be as descriptive, or you could have a 10-second elevator pitch as well. So, if you could wave a magic wand and fix one of the data problems across all environmental sectors, wow, that's a huge bucket. All environmental sectors, what would it be?
I'll go first. For me, it's data quality. It's such a massive issue across everything, but if we could solve that, then we could start actually tackling the issues at hand.
I think, of course, data quality, agree, Phoebe, 100%. I think added to that is the human attitude of the questions that we ask, what we apply our thinking to, where we put our eyes and our lenses and our thoughts and our minds, and solving the appropriate problems and the questions that matter.
I'd like to build on what Hyun was saying. Where does common sense prevail? Is commonly a question that we should be asking ourselves. And in line with that, how do we educate ourselves in order to answer the right questions and delve deeper into what the problem actually is before we proceed down a path around AI or anything else?
Amazing. Now, Amar, who asked the question on the dam safety management, says and did comment that there is an issue with data collection. Amar, we'd love to get in touch with you and understand what kind of issues you're facing. So please feel free to reach out to us. Some of the solutions that we've just described, and it has gone pretty far out in terms of technology. These technologies are based on zero shot learning, few shot learning, single shot learning techniques, reinforcement learning techniques. So you can collect some data and then it extrapolates. So we'd love to talk a little bit more in detail around what can be done regarding this use case. So thank you so much for asking that question. There's a question, I'll just open it up to the panel, and I'll maybe ask this to Phoebe because this builds on the previous question that I asked you. Suvadeep from the audience asks, should aspiring analysts focus more on domain expertise or advanced tech skills like machine learning?
I think there's a case for both, but as a consultant, I think that the tech skills are what's important. You can move across domains very easily if you have the tech skills and are working in the field that you want to be working in.
Perfect answer. And like Phoebe said, creative thinking.
I agree with Phoebe. The underlying tech skills are mandatory in order to figure out how to solve the problem. Understanding how to apply that is super important. So what problem are you actually solving? Not can you build a model, because you can build the model, it can work, but does it actually solve the problem? So as Phoebe said, it works hand in hand, but don't forget one without the other.
Amazing. And creative thinking, people skills, communication, all of this goes a long way. And by the way, I know that now I'm creating a big, huge laundry list of all of the skills that you need to have to get into this domain. It may sound intimidating, but really it isn't. The tech skills are a non-negotiable. But like Phoebe said, you can move across domains once you have the skills and the mindset where you can apply all of those skills that you've learned. Uh, that's all that this is about. Um, there's another one for you, Phoebe, very popular. Um, do animals have facial recognition? Can we do facial recognition the same way we do with humans with animals?
I'm not a zoologist, but I can talk about Tasmanian devils. So what I learned is that Tasmanian devils have white marks on the backs of their necks and other places on their body sometimes, and that is how you can tell them apart. So depending on the position of the Tasmanian devil in relation to the camera, you may or may not be able to see those white marks. So it may be difficult to tell them apart depending on the position that they're in. Not sure about if their faces are actually different though.
All right. I, for one, personally, I found them very cute. And I could tell the difference. All right. Another question. Do we have multifunctional teams, IT and domain specialists collaborating on such use cases? And then the applied AI team or the applications team as well to turn all of these models into usable applications. Does that mean we are using more resources than less? That's quite a conundrum. So that's really the question. So we have more human resources, more teams, IT specialists, analysts, application engineers, ultimately leading to more resources in a domain such as sustainability. So can we reduce it, or can we move towards more sustainable teams and such? How does that work?
I think it doesn't necessarily increase the team size. It's changing the composition of the team. So different people with different skills, different backgrounds, and working together in order to solve a problem. And of course, we have the benefit of AI and the data that sits underneath it to support the decisions that need to be made. So not necessarily bigger teams, but changes the composition of the team. And I think that's super important for solving those problems in a human way.
I think it also adds to the complexity of the problems that you are solving. I think both Des and Phoebe spoke of the case studies where the surface problems you're going beyond that by being able to apply AI and data and solving the complexity of those problems.
Amazing. Do we have any online resources on challenges and such case studies? Do you have any of these public? Where can our audience members access those?
I think the starting point is on our website, the Altus Consulting website. We've got quite a number of case studies there in this space and others. So start there, but if you can't find what you're looking for, contact one of the three of us and we'll be able to help. Most definitely.
All right. I see we are getting a lot of questions really around missing and messy data and synthetic data generation. See, when it comes to data generation techniques, if you have minority classes, you can try techniques like SMORT and others. There are multiple techniques out there that you can use to fill in the missing data. You could use synthetic data generation. Really, technology is not the limiting factor. It depends on the kind of use case that you're trying to solve for, and then you apply the domain expertise on top of it. So yeah, I think that should be an answer for it. We are reaching the top of the hour. I would take a moment to thank all of our speakers today, Hyun, Des, Phoebe. thank you so much for sharing these insights and these wonderful case studies. I'm deeply moved on what we're doing in this area. So thank you so much for sharing all of those insights with us. And for all of our audience members who've been asking questions, you can keep the questions coming in. Reach out to us on LinkedIn. We'll be more than happy to share some more insights with you. We could keep on going for another hour. These questions are brilliant, but let me make sure you leave with the clear next steps. So, if today has sparked your curiosity about what's possible with data, here's how to get hands-on Snowflake platform training. This is live, instructor-led sessions covering the AI Data Cloud, hands-on labs, real-world scenarios, and your own Snowflake account to practice with. Best part, it's free. Um, then we have virtual hands-on lab, guided tour of Snowflake, the AI Data Cloud. So if you want to keep building, join our virtual hands-on labs. These are guided interactive sessions where you learn by doing, not just by watching. So again, totally free of cost. Scan this QR code on your screen right now. Just take a quick screenshot with your mobile phone if you're on your mobile, or a quick screenshot of your desktop, and scan the QR code. And if you prefer self-paced learning, we have a lot of developer guides where we invest a lot of time and resources into creating product quick starts, industry use cases, and best practices. Again, all ready for you. Scan this QR code for instant access. Again, take a screenshot of the screen, your mobile phone, and go to our developer guides. Learn a little bit more. Now, this was the last in this series, but we are not done yet. We are starting another series coming July 2026. Mark your calendars. This is the Modern AI series. We'll share more details on this soon, but trust me, you'll want to be there. Stay tuned. With that, that's a wrap on our Earth Day special. A massive thank you to Hyun Choi, Phoebe Song, and Des Verena from Altus Consulting for showing us that data isn't just numbers on a screen. It's how we protect water, it's how we cut emissions, save species, and rethink waste. 4 use cases, 4 proof points that data is the most powerful tool that we have for the planet. And thanks to every single one of you for showing up. You could be doing anything else right now. Instead, you invested an hour in understanding how data and AI can drive real environmental impact. That matters. Happy Earth Day. A few days early. Now go to do something with what you've learned. And before you go, I need to tell you something. This is the final session, as I said earlier, of the Data and AI Fast Track as you know it. It's not the end. It's an upgrade. Coming June 26, we are coming up with a new series, the Modern AI series, talking all things vibe coding to AI career maps, completely new format, new topics, new speakers, and the evolution of everything that we've been building together. If you thought this series was good, get ready for what's next. Stay tuned. Thanks for being a part of Fast Track, and I'll see you in the Modern AI series. Enjoy the rest of your day.